All right, this lesson is on simplifying radicals, but this time we're looking at nth roots. So previously we've just been dealing with square roots, which is technically a root of 2. So we're going to be looking at higher roots. All right, so here's a little table that's just going to kind of show a pattern here. So let's start with 2, power of 2. So like let's say x squared equals 36. This is an equation asking you what values of x make this true. Well, let's think about this. 6 times 6 equals 36. Therefore, 6 is the square root of 36. And then we would also write that as the square root of 36 equals 6. So that's all review. We know square root. So now we're going to look at a higher root. Let's look at x to the third power. So what to the third power is equal to 64? So what number, when you multiply by itself 3 times, gives you 64? So 4 times 4 times 4, I know, is 64. Therefore, 4 is a cube root of 64. And then how we are going to write that is, so a cube root, it's like a square root, but with a little 3. The cube root of 64 is 4. All right, next one, x to the fourth is 625. What number multiplied by 4 times is 625? Well, 5 times 5 times 5 times 5 is 625. Therefore, 5 is a fourth root of 625. And then we would write that, so square root, but it's a fourth root. The fourth root of 625 is 5. So if we're going to look in general terms, a to the power of n equals b. That means that we have a multiplied by itself n times, and it equals b. This would be n times. Therefore, a is an nth root of b, or the nth root of b is a. All right, there's a way to take nth roots on a calculator. So I have 2 calculators. Here's a Scientific Desmos. They have a little nth root square root down here. You just have to press that and then you input which root. So let's say 4th root of 16, and the answer's over here, 2. Or on a graphing calculator, if you hit the math button, you see the different roots, but you have to tell what root first. So if you want 4th root, you have to hit 4, then math, go down to that number 5, x root. So that's saying the 4th root, type in 16, the 4th root of 16 is 2. So grab a calculator and practice typing in, evaluating all of these roots. I have 2 cube roots, a 4th root, and a 7th root. If you get a decimal, round to 3 decimal places. Why don't you pause, calculate them, and check your answers. So you should get the cube root of 343 is 7, the cube root of 75, 4.217, 4th root of 250, 3.976, 7th root of 3000, 3.139. All right, now we're going to get a little technical, and I have a little chart that's going to show how a might vary and how n might vary and kind of what happens. So let's start by just picturing values of a. So when a is greater than 0, or when a is positive, versus when a is less than 0, or a is negative. So let's look at how things change depending on if the root is even or odd. And for these, I like to look at a specific example first. So let's just think about this. Let's start with the square root of 16. So my root is even, my number is positive. So the square root of 16. Well, let's think. Well, 4 times 4 is 16. But the trick is also technically -4 times -4 is also 16. So when you have an even root and a positive number, technically it has a positive and negative answer, positive -4. It's just that we usually only write the positive 4, and we call that the principal root. So now let's look at when a is positive still, but when the root is odd. So let's look at the cube root of 27. Well, 3 times 3 times 3 is 27. That is the only possible combination. We can't do a negative because 3 negatives does not equal a positive. So this is only a positive answer. So what happens when now a is negative? Okay, and we have an even root. So let's look at an example. Square root of -4. So square root, so that's an even root, and I have a negative number. Well, that is no real roots. So you've learned that we have to deal with imaginary numbers there. That would equal a 2i. And then the last example, so a is negative, but this time we have an odd root. So let's look at an example. The cube root of -64. Can we take the cube root of a negative? Well, -4 times -4 times -4. 2 negatives go to a positive, and then a positive times a negative does go to a negative. So you can have a negative, but you cannot have a positive. So this is -4. So a quick recap. When the root is even, if it's positive underneath, you technically have 2 real answers. The principal one is just the positive one. If it's negative, no real roots. But if it's odd, if it's positive, you get 1 positive. If it's negative, you get 1 negative. Okay, now to simplify different roots. So I have an important message up here that I'm going to ignore for like 2 examples, then we're going to come back to it. So let's say I have the 6th root of x to the power of 36. So when we're dealing with powers, this is basically the same thing as x to the power of 36 raised to the power of 1/6. So when you multiply, it's the same as just dividing by 6. So it's like you take the power underneath, divide it by the root. 36 divided by 6 becomes x to the 6th. All right, the next one, the cube root of 125 times y to the 15th. Just like square roots, you can break those apart. We'll take the cube root of 125, either mental math or on a calculator, and then the cube root of y to the power of 15. The cube root of 125 is 5, and then here, 15 divided by 3 is 5, so it becomes y to the 5th power. Okay, so now before we do this one, let's read our special message that applies to only certain types, which, hint, 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 it's going to be this one. All right, so let's read it. When you find an even root of an even power, even, and the result is an odd power. All right, let's pause for a second here. Let's think about this. Well, let's see, 12 divided by 4 is 3, so x to the 3rd power. So I've got 4 even, 12 even, but the result is odd. Okay, it says you must use the absolute value of the result to ensure that the answer is a non-negative. So absolute value of x to the power of 3 is technically the correct answer, and it has to do with that slide that we just did previously about fourth roots can only have even roots can only have positive answers. All right, here are 3 more examples. I want you to pause the video, try them on your own, and then come back and check your answers. All right, so 5th root of 243 is 3, and the 5th root of x to the 10th is x squared. The 8th root of x to the 16th is x squared. The 8th root of y to the power of 24. I've got y to the 3rd, and I have it in absolute values because even root, even power, where the result is odd. All right, and then 6th root of 4096 is 4, and the 6th root of x to the 12th is x squared. So there's your lesson on simplifying radicals using nth roots. Good luck.